Hello children, this is Dr. Jayanth from Siddhaganga, the pride of Davangere. Yesterday we learnt about standard angles and their values and we solved all the problems from your text. And today we shall study about trigonometric ratios of complementary angles. What do you mean by complementary angles? If the sum of two angles is equal to 90 degrees, then those two angles are called complementary angles. So complementary angles are two acute angles whose sum is going to be 90 degree. For example, you have a triangle ABC where angle B is 90 degree and you have other two angles, angle A and angle C, and you know that the sum of three angles of a triangle should be equal to 180 degrees. So if one of the angle is 90 degree, then the sum of other two angles must be equal to 90 degrees. Therefore, angle A and angle C must be equal to 90 degree. They are called as complementary angles. Therefore, angle A and angle C are complementary. Why? Because the sum of angle A and angle C is going to be 90 degree. So, we have trigonometric ratios for complementary angles. We shall see that. So, first we will find out what are the normal trigonometric ratios for angle A and angle C. For angle A, sin A is given by, sin A is what? For sin A, BC is the opposite side and AC is the hypotenuse. So therefore, this is BC by AC. And what is cos A? Cos A is equal to, so cos A adjacent by hypotenuse, it is AB by AC. And what is tan A? Tan A is equal to opposite by adjacent, that is BC divided by AB. And what about the reciprocals of these? So sin A will have a reciprocal called cosecant A. So cosec A is going to be BC. So this is the reciprocal of this. And what about cos? The reciprocal is sec A. Sec A is equal to AC by AB. And similarly, cot. Cot A is equal to the reciprocal of tan, that is AB divided by BC. And in this triangle, if the value of this is A, then the value of C must be 90 minus A. How is that? So first you need to know that angle A plus angle C is equal to 90 degrees. Why? Because they are complementary to each other. And if you want the value for angle C, so angle C is equal to, you can shift angle A to that side, that makes it 90 degree minus angle A. So angle C is 90 minus A. Now, with respect to angle C, where it is 90 minus A, we will write all the trigonometric ratios what we have written here. So first, we will go with sin. Because we are considering angle C, this is 90 minus angle A. So we'll take it as 90 minus A, which is equal to, for this angle, the opposite side is AB and the hypotenuse is AC. Therefore, the sine of 90 minus A is equal to AB divided by AC. And similarly, for cos 90 minus A, which is equal to, for cos, BC is the adjacent, so adjacent by hypotenuse, which is BC divided by AC. For tan 90 minus A is equal to, so tan is what? Opposite by adjacent side, therefore AB divided by BC. And let us write the reciprocal functions of these. For sine, we have cosecant 90 minus A, which is equal to the reciprocal of this. that is AC divided by AB. And for cos you have sec 90 minus A, which is equal to AC divided by BC. And for cot 90 minus A is equal to, so reciprocal of this, that is BC divided by AB. Now we have written all the trigonometric ratios and their inverse for both angle A and angle C. When you observe this, what you can see that the ratios of the sides that you can relate on the right side. So here we have BC by AC, and what you can see that the ratios of this side will relate to some of the ratios on that side. Let us find out to which ratio this corresponds. So here we have BC by AC, that is for sin A. Where is BC by AC? If you can see, BC by AC is here. So therefore sin A and cos 90 minus A will have the same ratios of their sides. Therefore you can conclude that sin A is equal to cos 90 minus A. Why? Because you have BC by AC, BC by AC. Therefore you can conclude that sin A is equal to cos 90 minus A, or cos 90 minus A is equal to sin A. And similarly, we'll just find out which and all will relate together. Now we have AB by AC here. Where is AB by AC? Here. So you can relate cos A is equal to sin 90 minus A. And here you have BC by AB. Where is BC by AB? BC by AB is here. So you can relate tan A to cot 90 minus A. And you have AC by BC here. And where is AC by BC? AC by BC is here. So you can relate cosecant A is equal to secant 90 minus A. And you have AC by AB here. AC by AB. And you can relate these two. Secant A is equal to cosecant 90 minus A. And for the last one, AB by BC. So where is AB by BC? AB by BC is here. So you can relate cot A is equal to tan 90 minus A. And for the complementary angles ratios, you have relation between sine and cos. And similarly, you have a relation between tan and cot, and relation between secant and cosecant. So you need to remember there is a relation between sine and cos, secant and cosecant, tan and cot for complementary angles. So what you can say that cos 90 minus A is equal to sin A. Similarly, sin 90 minus A is equal to cos A. And for cosecant 90 minus A, you have secant A, and for secant 90 minus A, you have cosecant A. And for tan 90 minus A, you have cot A, and for cot 90 minus A, you have tan A. You have relation between sine and cos, tan and cot, and secant and cosecant. So with this, after understanding this, we will write the relation of these complementary angles in a single table. And we will represent all these complementary trigonometric ratios in a single table. Repeat after me. First, sine 90 minus A is equal to cos A. Very good. So what is cos 90 minus A? So is equal to sin A. What is tan 90 minus A? Is equal to cot A. And what is cot 90 degree minus A? Is equal to tan A. And what about secant 90 minus A? It's cosecant A. And what is cosecant 90 minus A? Is equal to secant A. So wherever you find an angle, you can always get a complementary of that by putting cos to sine and sine to cos, tan to cot, cot to tan, and cosecant to secant and secant to cosecant. with one of the degrees as complementary. For A, the other angle you can take is 90 minus A. For theta, you can take the other angle as 90 minus theta. For 20 degree, you will take 90 minus 20 degree. Okay, so we'll solve few problems based on this. So here is example 9, and you need to evaluate the value for tan 65 degree by cot 25 degree. First, you need to notice that these are not standard angles. We discussed about 0, 30, 45, 60 and 90 degrees, and these are somewhere in between values. And whenever you want to tackle with complementary angles, first you need to find out whether the sum of these two angles are 90 degree or not. So 65 plus 25 is 90 degree. Therefore, you can write the complementary ratios for this. So how you are going to evaluate this? So any one of the angle you can take a complementary. So this is equal to, so what you can do, tan 65 divided by, for cot you can take the complementary. What is the complementary for cot? It is tan 90 minus 25 degree. If there is angle A, cot A is equal to tan 90 minus A. So if I have 25 degree, you are writing the same 25 degree here. Now, so this tan 65 degree divided by, now you have tan here, and what is 90 minus 25 degree is 65 degree. So you have 65 degree for tan, and both the values are same. You can divide, and the value of this is going to be 1. And you have similar type of problems in your exercise. We'll solve one by one. First is sin 72 by cos 18. So these are not standard angles. Then what you need to find out whether they are complementary or not. So 72 degree plus 18 degree is going to be 90 degree. Therefore, you can apply complementary ratios. So how you are going to solve this? So you keep one of the angle like that. And for cos complementary, what you can take? Sin 90 minus 18 degree. So which is equal to sin 72 degree divided by, you have sin 90 minus 18, which is sin 72 degrees. And you can divide this, the value is 1. So for complementary angles, first you need to find out whether the sum of those two angles are 90 degree or not. If that is the case, then you can directly go into the complementary ratios. Here is the second main problem. So we'll start with the first problem. Tan 48, tan 23, tan 42 and tan 67. So first you need to find out which are the complementary angles in this. So you have 48 here and 42 here. If you add these two, 48 and 42, you are going to get 90 degree. Therefore, these two are complementary pairs. And tan 23 and tan 67, these two are complementary angles. So you can keep tan 48 as it is and tan 23 as it is. And what you can do is for tan 42, you can take complementary. So tan 42 is complementary is cot 90 minus 42 degrees. And for 67 also you can take complementary cot 90 minus 67 degree. Now you can take tan 48 as it is, tan 23 degree. Now this is cot 90 minus 42. What is 90 minus 42? Is 48 degrees. And this is cot 90 minus 67 is cot 23 degrees. Now we need to prove that as 1. Now you can see that you have tan 48 and cot 48. So these two are reciprocal ratios. So what you can write is tan 48 degree into tan 23 degree. This you can write it as 1 by tan 48 degree into, this is 1 by tan 23 degrees is equal to 1. So now what you can see is you can cancel tan 48 and tan 48, and you can cancel tan 23 and tan 23. So when you cancel everything, what is left is 1. So LHS is equal to RHS. Therefore, so you have proved that LHS is equal to RHS. That means tan 48 into tan 23 into tan 42 into tan 67 is equal to 1. And now we have one more problem here. We'll solve it here itself. First, you need to find out what are the complementary pairs. So 38 and 52, are they complementary? 2 plus 8 is 10, 1 carry, 6 plus 3 is 9 though. So this is complementary. So what you can do, you can take one of the ratios as it is and you can convert cos into sine. So what you can write is sine 90 minus 52 degrees minus. So here you can keep sine 38 as it is and you can convert one of this. So sine can be converted into cos 90 minus 52 degrees. So this is cos 38 degree into what you can write is sine 90 minus 52. What is that value? 90 minus 52 is again 38 degrees minus here you have sine 38 into you have cos 90 minus 52 is 38 degrees. So that you need to prove it as 0. Now we can see that you have cos 38 sine 38 and here also you have cos 38 sine 38. These two are one and the same values. So when you subtract the same values, then you will get 0. So 0 is equal to 0 and LHS is equal to RHS. So that means cos 38 into cos 52 minus sine 38 into sine 52 is equal to 0. So here we have two problems, one from worked example and the other from the exercise. So here what they have given, sine 3a is equal to cos a minus 26 degree, where 3a is acute, then you need to find angle A. So they have given complementary, as you can see that sine 3a is equal to cos. So we can solve this using complementary ratios. What you can do, first we'll write sine 3a is equal to cos a minus 26. Now you can take complementary for this. So sine 3a, what is the complementary? For sine it is cos 90 minus 3a, which is equal to, you have cos a minus 26 degrees. Now you have cos and cos on the either side. So therefore you can relate 90 minus 3a equal to a minus 26. So now this is a pure solving of equation. What you can do, you can shift 3a on that side. So minus 3a will become plus 3a. You can shift minus 26 on this side. That becomes plus 26. So 90 plus, when you shift minus 26 here, it becomes plus 26 is equal to a, and you shift minus 3 on that side, it becomes plus 3a. So 90 plus 26, what is the value? It is 116, which is equal to a plus 3a is 4a. So you can divide 4. You can divide 116 by 4 to get the value of a. Therefore, a is equal to, so divide 116 by 4, that is, therefore a is equal to, so 4 2s are 8 and you are left with 336, 4 9s are 26, so this is 29 degrees. A is equal to 29 degrees. And here you have the same problem. So you can answer me while I will be solving. So tan 2a is equal to cot a minus 18. So what you are going to do? You can take complementary for this. Complementary is cot 90 minus 2a, which is equal to cot a minus 18. So you have cot on either side. So you can compare 92a. 90 minus 2a is equal to a minus 18. So what you are going to do? Shift 2a on that side, shift minus 18 on this side. So 90 plus 18 is equal to a plus 2a. So 90 plus 18 is 108, which is equal to 3a. So when you divide 108 by 3, you'll get the value of a. So 108 by 3, which is equal to 3 3s are 9. So you are left 1. 3 3s are 9, carry 1, it becomes 18. 3 6 are 18, so it is 36 degree. Therefore, A is equal to 36 degrees. So here we have two problems. Secant 4A is equal to cosecant A minus 20. You need to find the value of A. So how you are going to do? You can convert this as complementary. For secant, complementary is cosecant 90 minus 4A, which is equal to cosecant A minus 20. So you have cosecant on either side. You can compare 90 minus 4A with A minus 20. So what you can do, shift 4A on that side, minus 20 on this side. So 90 plus 20 is equal to A plus minus 4A becomes plus 4A. So 90 plus 20 is 110, which is equal to 5A. So get the value of A, you divide 110 by 5, which is equal to 5 2s are 10. So you have 1 left. So 10, 5 2s are 10. So the value of A is equal to 22. So 20 degrees. Now you have tan A is equal to cot B. You need to prove that A plus B is equal to 90 degree. And how you are going to do that? So tan A, you can take complementary for that. So for tan, you have cot 90 minus A, which is equal to cot B. So you have cot on either side. You can compare 90 minus A is equal to B. So now you can shift minus A on that side. So 90 is equal to B, minus A becomes plus A. So therefore you have A plus B, which is equal to 90 degrees. And here you have one worked example and one exercise problem, which are very similar. So you need to express cot 85 degree plus cot 75 degree as trigonometric ratios expressing between 0 degree and 45 degree. And here also you need to express sin 75 degree plus cos 75 degree in the trigonometric ratios between 0 and 45 degree. So we'll deal with both the problems. Cot 85 degree plus cos 75 degree. So you can write complementary for this as tan 90 minus 85 degree plus, for cos you can write sin 90 minus 75 degree. So this is equal to tan 90 minus 85 is 5 degree plus sin 90 minus 75 is 15 degrees. So now you have an expression which is equal to this. You had cot 85 degree and cot 75 degree. The same you have written with tan 5 degree and sin 15 degree. Here both these values are less than 45 degrees. So these two values are in between 0 and 45 degrees. And you have a very same worked exercise problem here. So we'll solve. Express sin 67 degree plus cos 75 degree between 0 and 45 degrees. What you are going to do? You take complementary for this. What is the complementary for sine? It's cos 90 minus 67 degrees plus you have cos. What is the complementary for cos? It is sine 90 minus 75 degrees. So now you have cos. What is 90 minus 67? So 10 minus 7 is 3 and you have 8. 8 minus 6 is 2. So cos 23 degrees plus you have sine 90 minus 75 is 15 degrees. So now you have the value less than 45 degrees, between 0 and 45 degrees. Here is the sixth problem from your exercise. The clue what they have given, if A, B and C are the interior angles of a triangle, then you need to prove that sine B plus C by 2 is equal to cos A by 2. So the clue given is ABC are interior angles of a triangle. With that clue, you need to solve and show that sine B plus C by 2 is equal to cos A by 2. So according to data, what you can write is A plus B plus C angle is equal to 180 degrees. Why? Because sum of the interior angles of a triangle is always going to be 180 degrees. So here they have a relation between b plus c and a. So you can take b plus c here and shift a on that side. So that will make b plus c is equal to 180 minus a. And now you have b plus c by 2. So we divide the whole equation on either side by 2. So that makes it b plus c by 2, which is equal to 180 minus a divided by 2. So you can divide 180 by 2 and a by 2 separately here. So that will make a b plus c by 2 is equal to 90 minus a by 2. Now you can apply sign on both sides. So when I apply sign on both sides, it becomes sine b plus c by 2 is equal to sine, you have 90 minus a by 2. So this sine 90 minus a by 2. So by the complementary angles, you know that sine 90 minus theta is equal to cos theta. So this will lead to sine b plus c by 2, which is equal to, here you can write the complementary of sine, which is cos. So sine 90 minus theta is cos theta, cos a by 2. So this is what you needed to prove. Sine b plus c by 2 is equal to cos a by 2. With the help of complementary angle ratio, you have proved that sine 90 minus a by 2 is equal to cos a by 2. That makes it the proof. And complementary angle is the simplest part of your trigonometry. I think you are very intelligent. You can do these problems in seconds. After learning a pair of complementary angles, now we will move on to trigonometric identities. Identities you have already learnt in your previous classes. For example, a plus b whole square is equal to a square plus b square plus 2ab, which is always true for any values of variables for a and b. No matter whatever the values for a and b you are putting in, it is always going to be true for a plus b whole square, which is equal to a square plus b square plus 2ab. Similarly, you have identities in trigonometry also, where the identity will be true for all the values of its angles. And today we are going to learn 3 identities which are very important, thrilling part of trigonometry. You will really going to enjoy these type of problems where you use identities depending on your thinking ability. And we'll start with the derivation of one identity. Let us consider a triangle ABC with angle B 90 degree. So with respect to angle A, BC becomes a opposite side, AC is the hypotenuse and AB is the adjacent side. And now according to Pythagoras theorem, AC square is equal to AB square plus BC square. Now you have AC square, which is the hypotenuse. Now we'll divide the whole equation by AC square on both sides. So that makes it AC square divided by AC square, which is equal to AB square by AC square plus BC square by AC square. Now you can see that AC square could be written as AC by AC whole square, and similarly AB by AC whole square plus BC by AC whole square. Now what you can see that AC by AC is going to be 1, 1 square is always 1, so which is equal to. So AB by AC, if you look at this triangle, AB is what? AB is adjacent side. Adjacent side by hypotenuse will give you cos. So this is a ratio with respect to angle A, which gives you cos, and this is a ratio of the sides which represents cos for angle A. So this can be written as cos square A plus, what is BC by AC? With respect to A, BC is opposite side. So BC by AC is the sine ratio. So this is sine square A, and this is one of the most important identities. And here cos square A plus sine square A is always going to be equal to 1, no matter what angle you are putting in. So for 10th standard, the angle A is always in between 0 to 90 degree. So angle A is either equal or more than 0 or equal or less than 90 degrees. So here angle A is from 0 degree to 90 degrees, and for all the values from 0 to 90 degree for A, this value is going to be true. Therefore, this is called as an identity. So this identity could be written in three different forms. As you know, cos square A plus sin square A is equal to 1. You can shift cos square A on this side, so that makes it 1 minus cos square A, which is going to be equal to sin square A. Or you can shift sin square A on this side, so that will give you the value of cos square. So cos square A is equal to 1 minus sin square A. Whenever you see there is cos square A and sin square A, then you can always put 1 in that place. If you can see that there is 1 minus cos square A, that could be written as sin square A. If there is 1 minus sin square A, always you can write cos square A. And this is how this identity is used in solving different problems. We will write this identity here. So cos square A plus sin square A is equal to 1. You know cos square A plus sin square A is equal to 1. How did you get that? So by applying Pythagoras theorem, you got AC square is equal to AB square plus BC square, and you divided the whole equation on either side by AC square. Now with the help of this first identity, we'll derive other two identities. So you have cos square A plus sin square A is equal to 1. And now this identity will divide it by cos square A on both the sides. So that makes it cos square A divided by cos square A plus sin square A divided by cos square A, which is equal to 1 by cos square A. So what you are going to get, cos square A, when it is divided, you will get the value 1 plus, here you have sin by cos. What is sin by cos? It is tan. So you have sin square A by cos square A, which is equal to tan square A, which is equal to, you have 1 by cos square A. 1 by cos is what? Sec A. So this is sec square A. So this is the second identity where you have relation between tan and sec. So 1 plus tan square A is equal to secant square A. So in three different forms you can write. What are they? You can shift 1 on that side, so that will give you tan square A is equal to sec square A minus 1. Or you can shift tan square A on that side, that will give you sec square A minus tan square A is equal to 1. And with the same first identity, cos square A plus sin square A is equal to 1, will derive the third identity. So here you divided the whole equation by cos square A. Now here you will divide the whole equation by sin square A. So what you will get? Cos square A divided by sin square A plus sin square A by sin square A is equal to 1 by sin square A. So now you have divided the whole equation on both the sides by sin square A. So what you are going to get? This is cos by sin. What is cos by sin? This cot. So this is cot square A plus, here sin square by sin square A will give you 1, which is equal to 1 by sin square A. 1 by sin is what? Cosecant. So this is cosec square A. So this is another identity. So how you can write in three different forms. So cot square A plus 1 is equal to cosecant square A. So you can shift 1 on that side, that will give you the value for cot square A. Cot square A is equal to cosecant square A minus 1. Or you can shift cot square A on that side, so that will give you cosecant square A minus cot square A is equal to 1. So these are three identities. So we'll write all the three identities once again. The first identity is cos square A plus sin square A is equal to 1. And you have 1 plus tan square A is equal to sec square A. And the third one, cot square A plus 1 is equal to cosecant square A. So what you can see that all these identities are in the form of squares. So if you see squares in any problem, then you can think of identities. Without the squares, you cannot have an identity in that place. So you can observe that it is cos square A plus sin square A is equal to 1. 1 plus tan square A is equal to secant square A. Cot square A plus 1 is equal to cosecant square A. All these identities value are in the form of squares. So wherever you see square, then you can go for identities. If you want to put identities, you need to make the value in the form of squares. So while solving the problems, you will understand how you can put these values in the problems. So today we are going to deal with very simple problems to make you understand thoroughly. Let these identities get digested in you. Once these get digested, then it becomes easier for your brain to think for the problems. Learning all these identities, when it becomes very innate, reflex to you, then no matter how complex the question is, your brain can automatically think about the suitable procedure to get the answer. And this is a very, very tricky part. Getting digested with all the knowledge is very important. So it is mandatory for you to solve all the problems what I'm going to give you for the homework today. So one or two problems we'll be solving here, and the rest of them that you need to solve and develop your ability of your brain. Now we'll quickly write all those identities again, and we'll just find out, allow our brain to discover which identity can solve this problem. So the first identity is sin square theta, sin square A plus cos square A is equal to 1. And other two identities are 1 plus tan square A. So 1 plus cot square A. So now 1 plus tan square A is equal to secant square A, and 1 plus cot square A, 1 plus cot square A is cosecant square A. So these are the three identities. Sin square A plus cos square A is equal to 1. 1 plus tan square A is equal to secant square A. 1 plus cot square A is equal to cosecant square A. So just find out which suits this problem and what identity you can use here. You have 1 minus cos square A into cosecant square A is equal to 1. So just think and tell me. Yes, 1 minus cos square A, what you can write? Now for 1 minus cos square A, we'll take the substitution. So here you can see sin square A plus cos square is equal to 1. So here you have 1 minus cos square A. What is that? So when you shift cos square A on that side, so it becomes 1 minus cos square A. So sin square A is equal to 1 minus cos square A. Here you can substitute sin square A. If I substitute sin square A here, you have cosecant square A is equal to 1. So how you are going to prove this as 1? You know that sine and cosecant are reciprocals. So sin square A into cosecant square A, you can write it as 1 by sin square A. So sin square A into 1 by sin square A, where you can cancel these two and you will have 1 on both the sides. So this proves this problem. So it is important to identify which is the best suitable identity we can use to solve the problem. So this is how the problem is. Now even sin square A into cosecant square A, directly we can cancel and write 1 is equal to 1. Even that is also acceptable. To make you understand, I have written cosecant square A as 1 by sin square A. So we'll quickly do the second problem. 1 plus cot square A into sin square A. You need to prove that the product of these two is equal to 1. So here you can see that you have a square part. So 1 plus cot square A. So which identity you can use? It's a straightforward question. So 1 plus cot square A is nothing but cosecant square A. So directly 1 plus cot square A we can substitute as cosecant square A into, here you have sin square A. So which is going to be 1. How? Cosecant square A is nothing but 1 by Sin square A. So sin square A will get cancelled. So you will have 1 is equal to 1. And look into the third problem. Cosecant A into square root of 1 minus cos square A. So what do you think? Where you can put the identity? So here you can put the identity because you have 1 minus cos square A. So which identity you are going to take? So let us write this problem. Cosecant A into, you have square root of 1 minus cos square A. So what is 1 minus cos square A? You can use the first identity, sin square A. So when you take a sin square A out of the root, what it becomes? It becomes cosecant A into sin A. So can you cancel these two? Yes, you can. So because cosecant is 1 by sin and 1 by sin and sin will get cancelled. So therefore 1 by sin A into sin A will always get cancelled to give you the answer 1. So here also you prove that cosecant A into square root of 1 minus cos square A is equal to 1. Let us go to the fourth problem. Now I will allow you to think. Here you have secant square theta minus 1 into cosecant square theta minus 1. You need to prove that the product of these two is equal to 1. So here on both sides you can use identities. Which identity you are going to use? You have secant square theta minus 1. You can see here 1 plus tan square A is equal to secant square A. If you can shift 1 from this side to that side, what you are going to get? Tan square A is equal to secant square A minus 1. So here you can substitute that identity. What is this? Secant square theta minus 1 is nothing but tan square theta into. So what is cosecant square theta minus 1? So if we shift this 1 on that side, it becomes minus 1. That is cosecant square theta minus 1 is equal to cot theta. So you can substitute here cot theta is equal to 1. So can you cancel these two? Sorry, it's cot square theta. Can you cancel these two? Yes, you can. Why? Because tan and cot are reciprocal ratios. So tan square theta into cot, you can write it as 1 by tan square theta is equal to 1. You can cancel these two, which will give you 1 is equal to 1. So this is how you will use suitable identities wherever you find it is necessary. And during the solving of these problems, you may not know how to proceed, but the very immediate next step you can always do. So ಒಂದೇನು ಅಂತಂದ್ರೆ ಹೇಗೆ ಮಾಡಬೇಕು ಅಂತ ಯಾರಿಗೂ ಏನು ಐಡಿಯಾ ಬರಲಿಕ್ಕಿಲ್ಲ ಫಸ್ಟಿಗೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇಮಿಡಿಯೇಟ್ ಸ್ಟೆಪ್ ಏನು ಮಾಡ್ಬೋದು, ಸುಮ್ಮನೆ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಸೊ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕಾದಾಗ ಮಾಡ್ತಾ ಇದ್ರೆ ಅವಾಗ ಎಕ್ಸಾಮ್ಸ್ ಟೈಮ್ ಒಳಗಡೆಗೆ ಯು ಕ್ಯಾನ್ ಸ್ಕಿಪ್ ಆಲ್ ದೋಸ್ unnecessary steps and you can directly jump into the problems and get the solution. Now you can take down few problems. I want you to work independently. ನಿಮ್ಮ ಬ್ರೈನೇ ವರ್ಕ್ ಆಗಬೇಕು, ನಿಮಗೆ ಡಿಸ್ಕವರ್ ಆಗಬೇಕು ಹೇಗೆ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿ. ಎಬಿಲಿಟಿ ಡೆವಲಪ್ ಆಗಲಿಕ್ಕೆ 24 hours is more than sufficient. ಏನು ಐಡೆಂಟಿಟಿ ಇದೆ, ಯಾವುದನ್ನ ಹಾಕಿದ್ರೆ ಬರುತ್ತೆ, ವರ್ಕೌಟ್ ಮಾಡಿ ಆನ್ಸರ್ ತೆಗಿಬೇಕು. ಸೊ ಇಫ್ ಯು ಪ್ರಾಕ್ಟೀಸ್ ಟುಡೇ, ಟುಮಾರೋ ಯುವರ್ ಬ್ರೈನ್ ವಿಲ್ ಹ್ಯಾವ್ ದಟ್ ಕೆಪಾಸಿಟಿ ಟು ಥಿಂಕ್. ಸೊ ವಿಡಿಯೋನ ಪಾಸ್ ಮಾಡಿ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಡೌನ್. So here are a few more problems you need to write down. And here is the fifth problem. And in the previous examples, what we saw is there were squares and you could easily find out what identity you can use. But in this problem, you can see that there is no squares here. So if this is the case, if you want to use identity, then you need to make sure that you can create a square function. How you are going to do that for this? So here you have cos A by 1 minus sin A. So what I'm going to do is multiply and divide by the conjugate of this. So 1 plus sin A divided by 1 plus sin A. This is very similar to rationalizing the denominator. You already know very well. So what I have done is 1 minus sin a into 1 plus sin a will give you 1 minus sin square a. It is a square minus b square because it is in the form of a minus b into a plus b, which is a square minus b square. So on the top you can multiply cos a with 1 plus sin a. So cos a into 1 is cos a plus cos a into sin a is cos a sin a divided by, so here you have 1 minus sin a into 1 plus sin a, and it is going to be 1 square minus sin square. 1 square is 1, so you have sin square a. So this is in the form of a square minus b square. Now you have cos a plus cos a into sin a. You can take cos common here. So if you take cos common a, so cos a as common, you have 1 plus here you have sin a, and you have 1 minus sin square a, which is cos square a. So what you can do, you can cancel cos a and one of the cos out of cos square a. So here we are left with 1 plus sin a by cos a. So 1 plus sin a by cos a. And on the right side, you were needed to prove 1 plus sin a by cos a, and this is 1 plus sin a by cos a. Therefore, LHS is equal to RHS. So ಒಂದು ಏನು ಅಂತಂದ್ರೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದಾಗ ಹೇಗೆ ಮಾಡಬೇಕು ಅಂತ ಏನು ಐಡಿಯಾ ಇರಲಿಕ್ಕಿಲ್ಲ ಮುಂಚೆನೆ. So what you need to do, you just immediately think what is the next step that you can do. So mistake ಮಾಡ್ದಂಗೆ step by step ಮಾಡ್ಕೊಂಡು ಹೋಗಬೇಕು, no matter how many steps it takes. So if your brain can think better, you can get the problem within few steps. If you cannot think better, you may get after 3 more extra steps, but definitely you are going to get the answer. So more you can think, lesser the steps will be. So hagagi it is very important to apply your brain again and again, solve many problems. Repeatedly you can solve problems. ಆಮೇಲೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದೇ ಮೆಥಡ್ ಅಂತ ಏನಿರಲ್ಲ. So you can use different methods to solve those problems and you will really enjoy it. ಸೊ ಹೆಂಗೆ ಮಾಡಬೇಕು, ಏನು ಫಾರ್ಮುಲಾ ಹಾಕಬೇಕು ನನಗೆ ಗೊತ್ತಾಗಲ್ಲ ಅಂತ ಅನ್ಕೊಳ್ಳೋಂಥದ್ದಿಲ್ಲ. ಸೊ ಏನು ಮಾಡಬೇಕಿದೆ, ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಏನು ಮಾಡಬೇಕು. ಈಗ ಯಾರಿಗೆ ಮಾಡಬೇಕಾದ್ರೂ ಫಸ್ಟ್ ನೋಡಿದಾಗ ಇದು ಹೆಂಗೆ ಎಂಡ್ ಸ್ಟೆಪ್ಪಿಗೆ ಹೋಗ್ಬೇಕು, ನಾನು ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂತ ಯಾರಿಗೂ ಗೊತ್ತಾಗಲ್ಲ. ಸೊ ಎವ್ರಿಬಡಿ ವಿಲ್ ಜಸ್ಟ್ ಮೂವ್ ಆನ್ ವಿತ್ ದ ನೆಕ್ಸ್ಟ್ ಇಮಿಡಿಯೇಟ್ ಸ್ಟೆಪ್. ಒಂದು ಸಾರಿ ಒಬ್ಬ ಗುರುಗಳ ಹತ್ರ ಹೋಗ್ತಾನೆ. ಅವನಿಗೆ ರಾತ್ರಿ ಹೊತ್ತು ಕಾಡು ದಾಟಬೇಕಿರುತ್ತೆ. ಕಾಡು ಪೂರ್ತಿ ಕಗ್ಗತ್ತಲೆ. ಅವಾಗ ಗುರುಗಳ ಹತ್ರ ಹೋಗ್ತಾನೆ, ಗುರುಗಳೇ ನಾನು ಇದೇ ರಾತ್ರಿನೇ ಕಾಡು ದಾಟಿ ಹೋಗ್ಬೇಕಿದೆ, ನನಗೆ ಏನಾದರೂ ಒಂದು ದಾರಿ ಮಾಡಿಕೊಡ್ರಿ ಅಂತ ಹೇಳಿ. ಅವಾಗ ಆ ಗುರುಗಳು ಅವನಿಗೆ ಒಂದು ಲಾಂಟೇನ್ ಕೊಡ್ತಾರೆ. ಲಾಂಟೇನ್ ಗೊತ್ತಿರ್ಬೇಕು ನಿಮಗೆ, ಸಣ್ಣ ದೀಪ ಕೈನಲ್ಲಿ ಹಿಡ್ಕೊಂಡು ಹೋಗ್ತಕ್ಕಂಥದ್ದು. ಅವಾಗ ಅವ್ನು ಹೇಳ್ತಾನೆ, ಗುರುಗಳೇ ಇಷ್ಟು ದೊಡ್ಡ ಕಾಡಿದೆ, ಅಷ್ಟು ಕತ್ತಲಿದೆ, ನಾನು ಇದೊಂದು ಸಣ್ಣ ಲಾಂಟೇನ್ ಹಿಡ್ಕೊಂಡ್ರೆ ಕಾಡು ದಾಟ್ಲಿಕ್ಕೆ ಆಗುತ್ತಾ ನನ್ನ ಕೈನಲ್ಲಿ ಅಂತ. ಅವಾಗ ಗುರುಗಳು ಹೇಳ್ತಾರೆ, ನೀನು ಕಾಡಿನ ಆ ತುದಿ ನೋಡಬೇಕಾಗಿಲ್ಲ, ಲಾಂಟೇನ್ ಹಿಡ್ಕೊಂಡ್ರೆ ಮುಂದೆ ನೀನು ಎಲ್ಲಿ ಹೆಜ್ಜೆ ಇಡ್ಬೋದು ಅಷ್ಟು ನಿನಗೆ ಕಾಣುತ್ತೆ ಕ್ಲಿಯರ್ ಆಗಿ ಅಂತ ಹೇಳಿ. ನೀನು ಲಾಂಟೇನ್ ಹಿಡ್ಕೊಂಡು ಮುಂದಕ್ಕೆ ಹೋಗು, ನಿನಗೆ ಮುಂದಿನ ಬೆಳಕಿನಲ್ಲಿ ಮುಂದಿನ ಹೆಜ್ಜೆ ಏನು ಇಡಬೇಕು ಅಂತ ಕಾಣುತ್ತೆ. ನೀನು ಮುಂದಕ್ಕೆ ಹೆಜ್ಜೆ ಇಟ್ಟಂಗೆ ಬೆಳಕು ಇನ್ನೂ ಮುಂದಕ್ಕೆ ಹೋಗುತ್ತೆ, ಒಂದೊಂದೇ ಹೆಜ್ಜೆ ಇಡ್ತಾ ಹೋಗು, ಕಾಡನ್ನು ನೀನು ದಾಟ್ತೀಯ ಅಂತ ಹೇಳಿ. ಅವಾಗ ಅವನಿಗೆ ಜ್ಞಾನೋದಯ ಆಗುತ್ತೆ. ಹೌದಲ್ಲ, ಅಂತಿಮವಾಗಿ ಬಹಳ ಕಷ್ಟ ಇದ್ದಿರಬಹುದು, ಆದರೆ ಎವ್ರಿ ಗ್ರೇಟ್ ಜರ್ನಿ ಬಿಗಿನ್ಸ್ ವಿತ್ ಅ ಸಿಂಗಲ್ ಸ್ಟೆಪ್. ಸೊ ಸಿ ಯು ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್.